Hello, dear student friends. Today, the topic for this video is normal distribution. Now, let us see about the normal distribution, the Gaussian curve or normal curve, and also the relative deviate. So, what do you mean by normal distribution? So, whenever we record a data from a study and plot it on a graph, we get a distribution. When the distribution is normal, this distribution is called as normal distribution. So normal distribution is a form of symmetrical distribution, and it has an importance in statistical theory. So when we are going to analyze the data with the help of test of significance, that time we'll see how the normal curve or normal distribution is important. So normal distribution is also fundamental to the test of significance. So whenever we are applying a test of significance and we are deciding about the 95% confidence interval and probability, that time the concept of normal distribution is used. Further analysis of data is determined primarily by the shape of this distribution. So the shape of distribution of the curve will depend on the standard deviation of the observations. So what do you mean by normal curve? So normal curve with a large number of observations and a small class interval gives a frequency curve which is symmetrical in nature. So here in this diagram, you can see that the distribution is symmetrical in nature and it gives rise to a curve. So this is called as normal curve. Now the standard deviation in a normal distribution is the distance from the mean on the baseline. So here you can see in this figure that here is the mean x bar and the deviation from the mean on either side of the mean is +1 standard deviation, +2 standard deviation, and +3. Likewise on opposite side, -1 standard deviation, -2 standard deviation, and -3 standard deviation. So why these +1, +2, and +3, -1, -2, -3 are considered? Why? Because certain percentage of values will fall in this range. So if we take the mean +-1 standard deviation, 68% of the values will fall approximately. So if you take mean on this side +1 and -1, so this area you can see here it is given 33, 34, 34%. Likewise, for the 2 standard deviation from the mean. So this is -2 standard deviation to the +2 standard deviation. Almost 95% of the observations will fall. In case of 3 standard deviations on either side of the mean, almost 99% of the observations will fall. So these are the characteristics of the normal curve, which is commonly considered when we use the normal distribution. So these limits on either side of the mean are called as confidence limits. And most commonly used confidence limit is 95% confidence limit. That is the mean +2 standard deviation and mean -2 standard deviation that we'll see in the later part of this lecture. Now coming to the 95% confidence interval. So what does it mean? It means x bar +-2 standard deviation. Means 95% of the area of the normal curve and 95% of the distribution will fall in this range. Thus, the probability of a reading falling outside 95% confidence limit is 1 in 20. So p-value will be equal to 0.05. So when the p-value is less than 0.05, that the observation is likely to fall out of this normal range of normality, that is +-2 standard deviation from the mean. So the shape of normal distribution tells the probability of occurrence by chance or how often an observation measured in terms of mean and standard deviation can occur normally in a population. So these are all based on the distribution of the normal distribution. Now coming to the range of normality. This is not given in most of the books, but here I would like to give more stress because in the practical examination, questions are asked on normal distribution that are based on the range of normality. So we have seen in case of measures of dispersion, what is range? Range is the lowest limit to the highest limit. So in case of range of normality, it is the mean plus minus two standard deviation. So lowest limit will be mean minus two standard deviation, and the upper limit or higher limit will be mean plus two standard deviation. So if any value is falling in this range is considered as normal. So you can see that this much area of the normal curve will cover the plus minus two standard deviation or the range of normality. 95.5% of the observations will fall in this area. Now let us see one example based on the observation of the normal distribution and range of normality. A hospital record with the weights of every newborn baby were recorded. The distribution of weight is normal, mean is 3 kg, and standard deviation is 0.5 kg. So we have to determine percentage of newborn who weighed less than 2.5 kg. If 400 babies have been born at hospital, how many weighed less than 2.5 kg? This is the first question. Second question is percentage of newborn who weighed between 2 to 4 kg. And question number 3 is percentage of newborn who weighed more than 3 kg. So all these questions we can solve with the help of concept of range of normality or properties of the normal curve. So in the given question, information given is the weight is normal with mean is 3 kg and standard deviation is the 0.5 kg. So we have to take these values and calculate the further calculations. So first question is percentage of newborn who weighed less than 2.5 kg. So how we will do this? Now, just by seeing the values, you can see that 3 kg is the mean and 0.5 kg is the standard deviation. So if you take one standard deviation, the value will come to 2.5 kg. Means 3 minus 1 standard deviation, that is 0.5. So it will come to 2.5 kg. So here what we have to do, we have to calculate the range of mean minus 1 standard deviation. So 3 is the mean minus 1 standard deviation comes to 2.5 kg. And from the normal distribution, we know that 68% of the observations will fall in the range of x mean plus minus 1 standard deviation. So we have to make it half for minus side on negative side, because we have to calculate the weight less than, we have to calculate the percentage of children below 2.5 kg weight. So 68% will be between plus minus 1 standard deviation. So if we take only minus 1 standard deviation, it will be 68 divided by 2. That will be equal to 34% newborn babies will be born with birth weight less than 2.5 kg. Now, the second part of the question is that if 400 babies are born, how many will be having birth weight less than 2.5 kg? So here, out of 100, means 34%, out of 100, 34 are less than 2.5 kg. So if the 400 babies are born, then the number of babies will be, it will be 34 by 100 into 400. So 36 babies will weigh less than 2.5 kg. So like this, we have to calculate the number of children or percentage of children below 2.5 kg. And if 400 babies are born, how many will be born with birth weight less than 2.5 kg? Now coming to the second question, here it is asked that what is the percentage of newborn babies between 2 to 4 kg birth weight? So what we have to do, we have to find out the range of normality, that is mean plus minus 2 standard deviation. So first we need to find out the values for minus 2 standard deviation and then plus 2 standard deviation. So mean is 3, 2 into standard deviation, that is 0.5. So it is 3 minus 1, that is 2 kg. So this is the lower limit for normality. Then 3 plus 2 into 0.5 standard deviation, So that will come to the 3 plus 1, that is 4 kg. So the range of normality in this case is 2 to 4 kg, means 95% of the children will fall in this range. So the percentage of children taking birth with between 2 to 4 kg birth weight will be 95%. Now, third part is to calculate the percentage of newborn babies who more than 3 kg. So we can see that the mean value here is 3 kg. So mean value is the center observation of the normal curve. So half of the observations will be below mean and half of the observations will be above mean. So if mean is 3 kg, how many percentage of children will be above 3 kg? So here we can see that half of the observations will be the above, that is 49.5% of the children will be having birth weight more than 3 kg. So like this, based on the range of normality, we can do some calculations and find out the percentage of children falling in the range of 1 standard deviation, 2 standard deviation. Likewise, we can do it. So I hope that you must have understood from this example. Now coming to the standard normal curve. So there is only one standard normal curve with following characteristics. So it has certain characteristics. This is commonly asked in the theory exam as short note, and in the practical exam also, they ask you to write down properties of standard normal curve. And the other name for this standard normal curve is Gaussian curve. So what are the properties or characteristics of the normal standard curve? That the curve is smooth, bell-shaped, perfectly symmetrical curve based on infinitely large number of observations. So observations should be large in number. Total area of curve is 1, its mean is 0, and standard deviation is 1. So please remember that mean is 0, the standard deviation is 1, and area of the curve is 1. Its mean, median, and mode will coincide. So they coincide. The measures of central tendency for normal distribution curve will coincide. Theoretically, the normal curve does not touch the baseline or x-axis. So whenever you draw normal standard curve, it should never touch the baseline or x-axis, and it has 2 inflections. So these are the characteristics of the standard normal curve. The distance of value x from mean x bar in the curve is in units of SD, is called as relative deviate or standard normal variate, and it is denoted by Z. So Z is equal to the deviation of the observation from the mean divided by the standard deviation. So this is the standardized variable. A random variable x is said to have been standardized when it has been adjusted so that its mean is 0 and SD is 1. So based on the properties of the normal distribution curve, standard normal distribution curve, that mean is 0 and SD is 1, then we say that it is the relative deviate. So in this figure, you can see that if the Z value is 1 or plus 1, there will be 34% observations. If the Z value is 2, there it will cover 47.5% of observations. If the Z value is 3 or more, it will be around 49.85% of the observations. On negative side also, if Z is minus 1, 34%, minus 2, 47%, minus 3, 49%. So like this, we have the positive Z score and we have the negative Z score. Then these are all the other values of the Z are being given, and proportional area of the curve for corresponding Z value. So if the value is 0.5, the proportion will be 0.19 or 19%. If it is 1, Z value is 1, 0.34 or 34%, 1.5 Z value, 43%, 2, 47%, 3, 49%. So like this, depending on the value of Z, you can see that the proportion of the observations coming under that value of the relative deviate. Now coming to the estimation of probability. One example based on the Z value, mean pulse rate of a group of normal healthy males is 72 with standard deviation 2. What is the probability that a random male will have a pulse rate of 80 or more. So here we have to find out the Z value or relative deviate. So the observation is 80 and the mean value is X bar is 72. So 80 minus 72 divided by 2 is equal to 4. So area of normal curve corresponding to a deviate 4 is 0.49 or 49%. So we are dealing with only half of the total area. So we have to minus the 0.499 from the 0.5. So it comes to 0.00003. It means that the probability is 3 out of 1 lakh males to likely have pulse rate of 80 or higher. So like this we can estimate the probability or chance of occurrence of a particular observation. So Z scores are measurements of how far from the center or mean a data value falls. So if the Z value is 1 or plus 1, you can see here. So the observations will be 71.5%. And a man who stands 64 inches tall is 2 standard deviation below the mean. So it will be the if the relative deviate is 2, the 64% of the observations will fall below 2 or minus 2. So like this, we can estimate the percentage of people falling in different areas. I hope that you must have liked this video on standard normal curve, Gaussian curve, relative deviate. I hope that you will be able to understand it and solve the questions which are asked on the properties of normal distribution curve in the theory as well as in the practical exam. So thank you very much. Once again, I request you all, please subscribe my channel and like and share in your groups also. Thank you. Thank you very much.